Yeah, I can see
You
it.
guys see the screen?
Yep.
Okay, great. Okay, so our mission at we call ourselves DVNAUG. We started about 2 years ago, and we all had a common goal, which was to form awareness in the North American area about the benefits of adopting Data Vault for your information platform. And ironically, the author of Data Vault is an American, but we haven't adopted it as at the same pace as in Europe and in Australia and other places. And so we formed this group because it's just about awareness and letting people know that it is an option for your data platforms. So I did notice that we had about 25% of the people that signed up today are new. So first time to DVNOG. And I did notice that a lot of people really didn't know what it was and they wanted to learn what Data Vault was. So hoping that our session will provide that kind of information. But real quick, I just want to give you the basis for Data Vault. And it's a system of a business intelligence, and it contains the necessary components to build an enterprise vision for in data warehousing and information delivery. It's made up of three components: a model, the methodology, and the architecture. And it is not a tool. It's not a product. You don't buy Data Vault. Okay. It's a different way of thinking outside of the box and doing things differently. So the model, the key thing about the model is it's pattern based, and anything that's pattern based can be automated. And we have a number of vendors that you're going to hear from today that offer, I don't call them ELT or ETL tools. They are Data Vault acceleration tools. They really get you from 0 to 60, quickly, and get the data in front and the information in front of the business so they can start making their business decisions. So the pattern base is key. It's historical, it's granular, it's auditable, it's great for governance, it's resilient to change, it's scalable, and it's fault tolerant. So it's really key. Second is the methodology that we follow. We follow an agile methodology, and Data Vault allows us to do this. And key is it's business oriented. We start with the business. We don't start with the data. We start with the business. Then we marry their needs with the data so that we make sure that we don't build data swamps. We build things that that fulfill their needs. It's consistent and it's repeatable. And then the third component of Data Vault is the architecture. And one of the awesome things is it's platform agnostic. You can build it in SQL Server and Oracle, in the cloud, in Snowflake, in SynOps, anywhere. It can be built and utilized, and you can transport it easily. So those are the key things about Data Vault. I just want to make sure that everybody is aware of what it is. And over here, you'll see the let's see, you'll see like the objects. The core objects are what's called hubs, links, and satellites. But anyway, back into our presentation. Hopefully, that's a good explanation of what Data Vault is. So just to go over our agenda, I'm going to introduce the board. We're going to hear from our sponsors. The board members and the sponsors are what help enable us to provide this to you on a quarterly basis. We're going to be hearing from Doug, the data guy, Needham, and he is going to be speaking to us about building an enrichment platform with Data Vault. So first he'll have 15 minutes of speaking, and he'll be reviewing the fundamentals. And then we're going to hear from part of our sponsors. We have about 9 sponsors. So we'll hear from 5 of our sponsors. Then we're going to take a 5-minute break. And remember to, if you have questions, just put them in the chat. We've got Sam Bendian and Gail Bunn will be monitoring that and collecting those for our Q&A session at the end. Then after our 5-minute break, then we're going to have another 50 minutes with Doug, and he's going to go over building that enrichment platform. And then we'll follow up with the Q&A. And then we're going to have our Dan's Words of Wisdom. Dan Lindstedt is the author of Data Vault, and he's going to be going over the Data Vault certification program, which is now CDVP 2.1. And then he's also going to talk about the Worldwide Data Vault Consortium, which I think it happens in the end of April, beginning of May. And it's always a great place to go and network and learn as much as you can about Data Vault. And then we have at the end, super exciting, our sponsors donate $50 gifts, and we give those away to the registered folks who opted in. And we'll talk about the next event. So our board members made up of Cindy Meyerson, she's in charge of operations, Gail Bunn in charge of professional development, Keith Bellinger in charge of member services, Jim Freyer is our treasurer, I'm the president, Karen Edmond is the secretary, Sam Bendian is in charge of sponsorship, and Janet McFarland is in charge of event planning. And I wanted to note out to you that we will be voting on the board member positions starting in January. We like to rotate and give other people opportunities to be a part of this organization. So if you're interested, self-nominate yourself and email it to me at mary.mink@dvnaug.com, and we'll make sure that you are in the pool. Okay, so now we're going to be hearing from our sponsors. First up is Resultant. Is Kyle Cook on the line?
I am. Hey, Mary.
Awesome.
Hey, everybody. My name's Kyle Cook. I am a business development executive and partner manager over at Resultant. I work with the lovely Mary Mink and Gail and Sam as well. And so we're a data consulting firm out of Indianapolis, and our primary data location is down in Dallas, where I'm located. We help clients all across North America in 4 main focus areas that you can see down on this slide: data pipeline, data governance and strategy, data science, and data visualization. We also have training and enablement, which is mostly in tools that fit under at least one of these areas. So this graphic is really effective in demonstrating how we assist our clients with moving their operational data from point A, original data sources, files, business applications, all the way to being analytical data over at point Z. So polished reporting platforms accessible to end users, things like that. With all the different steps that are needed to get there in between. Our approach is simple: to work ourselves out of a job. We're a group of data experts, but we're in the business of making, teaching, and enabling and empowering data experts within their own organizations. So in our eyes, successful projects are determined by how self-sufficient our clients are when development is complete. We want to make our clients the experts of their own data solutions and help them to be real heroes to their end users and customers. We love Data Vault at Resultant and make up half of the DVNAUG board. We were one of the original foundational sponsors and have around 14 to 15 Data Vault clients with, I think, around the same amount of Data Vault practitioners. So come talk to us for your next Data Vault project. That's Resultant. Thanks, guys.
Okay. Thank you, Kyle. And next up, we have Vault Speed. Do we have Sean Johnson with us?
Yeah, I'm here. Thanks. Hey, thanks for having me, everybody. And of course, thanks to the user group. I think this user group is super valuable. I'm actually taking over for the esteemed Brian Mull over at Vault Speed, and I head up our US pre-sales team over here from a technical perspective. I wanted to thank the presenters and the content developers today. I think anytime we get new learnings, it's really valuable and very helpful for us as we grow in our careers. Quick little bit about Vault Speed. Vault Speed offers data transformation automation platform via cloud native SaaS platform for all of our large and mid-market enterprise companies. We are the T or the transform in the ELT process. So we're going to help you use or automate all of your repeatable processes using our streamlined and unique automation technique. So hope to reduce some of your workflow by as much as 96%. So that's who VaultSpeed is. Reach out to me if you guys have any questions.
Thank you, Sean. And next up, we have SQL DBM, Keith Bellinger.
Hey, everybody. Keith Blanchard here, product evangelist at SQL DBM. SQL DBM is call it the modern data modeling platform for the modern data practice. Though data modeling has not changed for much of the years, what has changed is what modern data practices need. So SQL DBM has been built from the cloud up, is a fully SaaS solution. So there's no technology that needs to be downloaded or keys to manage. We do support most of the cloud-based data platforms, so Snowflake, Azure, Synapse, Databricks, BigQuery, and others. Data modeling, as we all know, is one of the three pillars, but SQL DBM is built to support the other pillars in terms of methodology and architecture. So we talked about many of the data platforms, but also we integrate with source code management solutions, as well as other data project management and agile solutions like Jira, so that you can have that direct integration amongst those technologies. We also do some more advanced stuff in terms of the DDL and more organizations using YAML, so accelerating the ability to do YAML. And what's not here, but to come, is more and more advancements in accelerating teams who want to do data vault modeling. So we'll be creating what we call table templates. So a little bit different than automation, but the ability to accelerate the hubs, links, and satellites to the way you need them and to quickly be able to do those models. So definitely stay tuned for more to come in that space. And thanks for having us here.
Thanks, Keith. And next up, we have John Price from Seven Rivers, previously Performance G2.
Great. Thank you very much. My name is John Price, and I am with Seven Rivers. Super excited to be here today. As our slide is illustrating, Performance G2 and Seven Rivers have recently merged. This took place in October, and the new company is now Seven Rivers. Seven, as many of you may have been aware in the past, Performance G2 has always focused on Data Vault training, as well as Data Vault implementation services. And the new Seven Rivers company, we are continuing to provide all of those services. We love Data Vault and really view Data Vault as the true foundation for all data. And so as we now are building our new company of Seven Rivers, on top of that, we wish to simply add additional services on top of that foundation. And so Seven Rivers is going to continue to focus on Data Vault and additional value add services, bringing together new technologies such as AI and machine learning, and really help enterprises modernize their data platform and their data environment with focus on making sure that the data foundation is really solid. And that's why Seven Rivers is super excited to now be joined with Performance G2 and to be part of the Data Vault Alliance. So thank you very much.
All right, thank you, John. And next up, we have Peter Bellis, I think, from Data Vault Builders. Are you here, Peter? Is there anyone here from Data Vault Builder?
I don't see anyone online, Mary, from Data Vault Builder.
Okay, do you want to say something about Data Vault Builder?
No, I think we'll just leave their slide up if you don't mind, and let's move on.
Okay, all right. right, then take it from here, Cindy.
Thanks. We are really excited to have Doug Needham here. I have had the pleasure of knowing Doug for, as we'd say in the South, for a moment of time, for a bit of time. You guys may know Doug as the data guy. Doug Needham, he started his career as a U.S. Marine. Thank you for your service, Doug, by the way, as a DBA supporting their operational systems. Spanning the globe. So he was supporting operations across the globe. Since then, Doug has worked as a consultant, a data engineer, and a data architect for enterprises of all different sizes, often acting as a data scientist mentor. So while architecting new applications, design, and data product use case development, he defined data strategy, for a consolidated enrichment platform that produces data visualizations, and you utilize graph sort of technologies to produce content-based media player recommendations for past businesses. So Doug, I will tell you, Doug has a great deal of esteem in Dan's eyes, and when it comes to talking about data science, Dan is always like, I need to talk to Doug. I need to talk to Doug. So he and Dan have been friends for a number of years, and he's currently working, as a data scientist, tinkering. I'm going to say tinkering, Doug. You can correct me with graph databases, this enrichment platform, and a variety of other really cool tech. So, he's always showing others how to get more meaning from data with this continuous focus on data operations. It is with that kind of a background, I am pleased to introduce Doug. And Doug, just handing this over to you.
Thank you. So I'm gonna share my screen in just a moment, but before I do that and go through the presentation, I'm gonna ask for help from a lot of folks. So this will be the third time that I've given this presentation, and when I was a little nervous when I first put it together because and I did this in Vermont at the beginning of the year, and it was one of those things that I told Dan about some of my crazy ideas, and he's like, just bring them, just talk to people and share them, and let them tell you if they're crazy or not. Don't assume. Well, it was received very well both times that I gave it, and both times I've had multiple people ask me if I have a book to back this up, and so I actually started writing more details about all of this stuff in a manuscript, and I've got a long way to go. But the help that I'm going to ask of everyone is if you think of anything as I'm doing this presentation, because some of this stuff can be a little complicated. If you think of anything that would be helpful for putting this together in a manuscript, please reach out, send it to me, let me know. And then also the other thing is once I do get through the first draft of the manuscript, any volunteers that want to review it and then help give me feedback on that, I would appreciate. So I'm going to share my screen just a moment and we'll get going. Okay, can everyone see the presentation?
Yes.
Yes, we
All right, very good. I wanted to make sure I didn't have the speaker view present. Okay, so I work for a company called DataOps Live. I'll mention them briefly a couple of times through the presentation. So a little bit of background about me. Doug the Data Guy is the best search for me. It's just really easy to go with it. Now, I've had a few people ask me why do I go by the Data Guy, or why do people call me the Data Guy? Every organization that I've gone into has usually needed severe help in getting their data organized, whether this be on premise or in the cloud. And usually after firefighting for a little while, I'm able to get things at least organized enough to be able to start focusing on getting answers. So inevitably people come to me and say, hey, I need this data. Hey, I need this data. And so I just inevitably people start calling me the data guy. So I've worked with relational databases since before Desert Storm. That was called out to my part of my career in the Marines. I've been a DBA, data architect, data scientist. I'm certified with Data Vault. Snowflake. I've had certifications with SQL Server, Oracle, etc. So I've worked with a number of different relational databases. Um, the first published book that I have out is called The Enrichment Game, and it is talking about why do you need an enrichment platform, and I'm going to define an enrichment platform here shortly as to what that is, and you may be surprised at learning the definition. So anybody that wants to talk about data just in general, reach out. Let me. I'm always happy to talk about this stuff, and as you will see, as we get through the presentation, I'm very much a nerd. So uh, let me know. All right. So this is one of those. I have to expand the whole thing because it's a play out. Just a moment. One of the things that I borrowed this from the Data Ops Live sales presentations, but one of the things that I like about this, and the reason that I stole this from, borrowed it from my company, is we don't talk about, we have not, up until recently, talked a lot about the automation of getting things built within data infrastructures. There are a lot of people that I know personally, as well as through the community, that can build out everything from a data ecosystem top to bottom with no problem. They have the expertise. The problem is where I think it comes into play is it's going to take you a long time to do that. So some of the vendors that the sponsors that we have, please take a look at some of the things that they are presenting. Carefully consider them for your environment. Look at the cost justifications because the time you save using a vendor and learning how to use that vendor, whether that be a platform or a tool, what have you, um, you're going to take advantage of it. And I'm going to show you ways to take advantage of it by relying on tools to take care of some of these low-level details. And just touching on some of the math, there is a paradox that I learned about not too long ago. It's called Jevons paradox, and I'm going to read the definition. In economics, the Jevons paradox occurs when technological process or government policy increases the efficiency with which a resource is used, reducing the amount necessary for any one use. But the falling cost of use increases its demand, increasing rather than reducing resource use. So as you go into the way I interpret that from a data ecosystem need, as you go into the world of putting together a data platform, you start, and I've experienced this paradox personally a number of times, as I mentioned before, going into new environments. You start making things more optimized, you make it easier to use and easier to get to data, you're going to get more requests. And then depending on how you built your infrastructure, your ecosystem, what have you, it can become overloaded because you didn't necessarily build it for scale. You built it to solve an immediate problem, and now you've got to re-engineer it and on and on. So something to consider. So I strongly encourage reviewing uh, information from all of our sponsors. Okay, so now to get started, first principles. These are the first seven definitions from Euclid. From these first seven definitions, which are illustrated by these first three images, point has no part, a line is a breathless length, a straight line is a line with even points on itself, a surface has length and breadth only, and then you can even increase that to volumes. So this is so once you get a fourth vertex here, you actually have a volume. Um, the principles of data engineering are a little different from the principles of software development because we start with data. And one of the analogies that I want to share with you guys, when I first moved to Cincinnati about 10 years ago, I heard the story about growth of little things here in Cincinnati, entrepreneurship. In the early to mid 1800s, Cincinnati was known for its pork. There's a lot of farms nearby. People would bring their hogs to Cincinnati and sell them. And then, of course, butchers would do the things that they do to turn hogs into pork and what have you. Then they would ship them off to Philly, New York, whatever. These companies that were based here were very focused on the most efficient ways to turn those hogs into pork products. But the one thing they could not use was the animal fat. Along came these two guys who immigrated to Cincinnati. William was from Britain and James was from Ireland. They met because they actually married these two sisters, Olivia and Elizabeth. They weren't butchers, they weren't ranchers, they weren't farmers. One of them was an expert in candle making, the other was an expert in making soap. So they did see a use for that animal fat that was being discarded and being considered useless. They went around and asked all the butchers if they could collect all the fat that was being thrown out. Butchers had no use for it. It wasn't part of their business process. It was not part of their um, daily business because their business was producing sausages and such. So they started making soap from all of this animal fat that the butchers were giving away. They didn't have a use for. Um, their actual names were William Proctor and James Gamble. So you might have heard of the company Procter and Gamble that came about later on. So I'm going to show you part of what I'm going to show you is a process for creating something new from what was discarded from our friendly neighborhood butchers, the application development teams, because data is not necessarily their primary focus. When they're creating applications, their goals are driven a little differently than what the data engineering teams are driven for. All right, so one of the things, first part of this presentation, we're going to talk about a lot of definitions. And then, as Mary mentioned, the secondary hour, we're going to be putting a lot of those definitions together. I had originally done this whole presentation in an hour. I'm actually trying really hard not to talk fast because I got ingrained that I had to talk fast to get through this material. So I'm going to try to talk a little slower, but we may end up with a little bit of buffer time just because of the way that I put it together. So from a definition perspective, an axiom, postulate, or assumption, it's just something that is taken to be true. You no matter what, whatever your starting point is, you have these axioms. You're going to assume it to be true. You're not necessarily going to check it, what have you, but then you can build on those things. So I call this a stair step approach. You start with step one, and then you go to step two, and on and on. One of the things that is some of the things related to our data ecosystems is there are a lot of things that need to be done sequentially. They just have to be. Um, there are also things you can do in parallel, but you cannot mix the two. If something has to be done sequentially, that is the only way to do it. You might be able to do some tricks, a few tricks here and there, or change some stuff. But if something is required to run sequentially, it just has to run sequentially. Um, one of the stories that I love to tell folks is I had a project manager once when I was explaining that we hadn't got the terabytes of data loaded in the Snowflake for doing analysis. The project manager came back and said, "Well, what kind of analysis can you do before you load the data?" Uh, um, okay, sure. I can guess, but that's you have to do one before you do the second. All right, so a lot of the stuff that we work with daily, we've got database terms, business keys, relationships, context and measures. In mathematical terms, these are sets, tuples, and traits. And these are the easy parts. And how do we get from our data infrastructure to the business world? I think there's and I'm going to show that there is an opportunity to use the mathematical world to make that transition, and that by doing that, the transition becomes a little bit easier. Okay, so don't be scared of this part of it because this might give you flashbacks to grade school. But a set is a collection of objects that are unique, and that is, I mean, that's just the purest definition of what a set is. Uh, you can have the this 1, 2, 2, 3, 3, 3 and 1, 2, 3. Those are equivalent because a set is defined as a unique set of objects. Um, there's also a common language of set theory called set builder notation, which is what I'm going to be using throughout this. So this set builder notation says that the set X exists such that X is in the domain D. That's all it is. It's just defining what is the definition of the set. Now, the definitions of sets become really interesting as you get things a little bit more sophisticated. This was I'll mention in Vermont, for those of you that were there, you might have remembered some of this. I called out some things related to Chris Date's examples, and then Chris spoke in the afternoon, and he mentioned the same examples. So I had a number of people look at me whenever that happened. So that was a little humorous. But going back to definitions, so in the original papers that Cod wrote and then Date enhanced on, a relation is the structure of the collection of elements where an element is a name paired with a domain or data type. So the element, so each of these columns, they're considered to be a set, but by the original COD definition, this set is, the domain is set by the type of data that is going to be stored here, as well as the name. So these two things are different. They're different domains because you can see this is an integer and occupation is text. So those two things are going to be slightly different. And then again, in the way that he put together the definition of what a relation was, you cannot have two attributes with the same name. And so a relation, we can think of that as this definition up here, that first row, where all of these guys through what's called a finite relation in set theory, they're related to the primary key. You have the alternate primary key, the name, blah, blah, blah. Each of these rows are related to this, but the relation is the structure of it. Another term called a relvar, this is the implementation of a relation. So a relvar is what we would consider to be a row. In the early, again, going back to the original definitions, a relvar is a set of n tuples where each element is implemented value conforming to the attribute specification. And then the tuple is just a finite sequence of elements. So when we look at, I made a reference here to Date's work if in, I forgot the name of the book, Database Systems, 4th edition, I believe it is. Whenever you define an employee, and according to the parts and suppliers database that Date used to write, that Date has written about a lot, this is all predicate logic. So employee number is named ename, works in department number, and earns salary, a given salary. And this is another definition from him. A given relation, the heading of R denotes a certain predicate. The predicate is just a truth valued function, like all function, and it takes a set of parameters. So those are going back to some of our early definitions. So a relational data model, I added a little bit of stuff to this here, where we have a mathematical definition of a data model, which a data model D is a set of relations where the relation is in the set of alpha, and alpha is the domain of relations that are for a particular business subject area. So all of relational algebra, calculus, SQL development, and most relational data modeling all exist within this set. Now, a set of foreign keys. The set of foreign keys in a data model are the keys that satisfy the property. The foreign key of one table is equal to the primary key of the other table. This is the mathematical definition of what a foreign key set is. We're going to tie these two together here in just a second. Now, an entity relationship diagram, many of you are familiar with these, but just touching on making sure we all have the same definitions to work with before we get to the second part. This is an ERD I created for my in my book, The Enrichment Game. Very simple. It's never really been implemented, but I make reference to this a couple of times. Now, one of the things about data modeling that comes up that has come up in my experience dealing with new applications, new ecosystems, etc., is that there are a lot of people that have this philosophy of you do not need to design anything. That's a waste of time. There's no business value to creating any design models, ERDs, or schedules, or any of that kind of stuff. Well, I heartily disagree with that for a variety of reasons, but I'm going to show you how to get additional value out of these design documents using a few math tricks. One of the things that I came up with, or that I started calling a data structure graph, is really an ERD, but it is a mathematical representation. So a graph, this is a mathematical definition, is an unordered pair of sets, vertices and edges, where V are the vertices and E are the edges. So this is a vertex, each of the little circles, and then the lines, these are edges between them. Now, referring back to those definitions that I just made earlier about D and S, you have, given that D is a set of relations and S is a set of foreign keys where the relation shows one thing between another, a data structure graph is a graph using D as the set of vertices and S as the set of edges. This is a proof that an entity relationship diagram is a graph by definition, if you put that into that from that perspective. So, and a graph has a mathematical definition of what it is. I'm not going to be able to show a physical demonstration like I did in Vermont. Usually what I do is I have a little bit of some balls of yarn and I toss them into the audience, and everyone has to duck and run for that one. But it is, I'm not going to be able to do that obviously because we're remote. Now, one of the newer things that I'm recently working on is this idea of a data structure topology. One of the differences between a topology and a graph is topologies have fixed lengths. So when we get to where to how data is moving through an enterprise. So if you think of a data structure graph as a data model for an individual application, that graph, the length between the tables is almost nothing because you could just do joins there, right? Or you can do multiple joins and you'll have a length if two tables are separated by an intermediate table, like in my ERD. However, those lengths are not fixed. It can vary, the lengths for how the graph is used can vary based off how queries are written against that data model. With a topology, you're going to have the lengths that are a little bit more fixed. And so when we are working with systems where we have to do ELT processes, where we're going to extract data from system one, load it into an enrichment platform, and then transform it into useful data products, that movement from the source system to the target system is that's where your length is. So you're going to have you're going to go from having multiple graphs in your data ecosystem where you're looking at individual data models potentially from multiple applications. That could be Salesforce, that could be your financial system, that could be your ERP system, your CRM system, etc. Each of those are going to have their own data models, hopefully, and then or at least their own use of the data models. And then so you're going to be connecting to in those individual data models and pulling data into a common repository, your staging area at least, and then ultimately creating a data vault and other data products from that. So by doing that extract part, you now have a length of one, which is where you're moving data from one system to another. Then as you go from the staging area into your presentation layer or where your other data products are, you're going to have a separate length there where it may not be so much a physical move as especially if you're working in the same database, but there is a logical differentiation between your staging area and your data vault and then ultimately your presentation layer. So each of those you're going to have other steps. So this then becomes more of a topology versus a graph. And one of the reasons why I'm making such a big difference between, or calling out the differences between a topology and a graph, is they both allow and require different types of mathematics that can be done structurally to each of those things. So if you're looking at how something is working, from how data is flowing from one part of the enterprise to the other part of the enterprise, that's very different than looking at how data models are structured and what kind of performance you can get out of the individual queries. So an application data model, I made reference to this a little bit earlier. This is going to be the data model that is within an application. So within your CRM, within your ERP, within your custom built application that you expose through a mobile app that your customers are using. That's your application data model. An enrichment data model is a little different. And why do I call it an enrichment platform? So here is, spoiler alert, here's where I talk about what an enrichment platform actually is. I've worked for too many people that just really freak out whenever you say we need to create a data warehouse. We don't have time to create a data warehouse. We don't have the resources. There's only 2 people on the data engineering team. We can't build a data warehouse. Okay. Well, one of the things that I started doing when I was working at a startup a few years ago, I said, well, what if I put together just an enrichment platform where we bring data together from multiple places and make it easy to use? Oh, yeah, okay, that's fine. All right, cool. Then I'm going to build an enrichment platform. And we're going to, from the enrichment platform, we'll create all these reports and we can do visualizations and other stuff. Yeah, that sounds great. Awesome. Cool. I'm now working with enrichment platforms. Now, a dimensional data model is denormalized for reporting purposes. So there are only 2 types of tables that you're going to have, and these are called dimensions and facts. There's several different types of dimensions and a few distinct types of fact tables depending on certain things. But in general, you're going to have dimensions and facts in a dimensional data model. There's some, we'll come back to this later, more interesting things to be done with that. So Data Vault. Mary mentioned earlier that there's a few people that are not that familiar with Data Vault structures. That's great. That's fine. Welcome to the party, where we'll talk a little bit about this, and I'll show you some interesting ways where you can use Data Vault structures. But here we're going to do a few definitions. So one of the most important topics when designing a Data Vault structure is the business key. And Dan has has lots to say about what a business key is, and I'm not going to try to duplicate what he says, but it's really, a business key is how an end user is going to identify, an analyst is going to identify potentially a customer. So it could be an account ID, things of that nature, customer ID, all of that kind of stuff. Those are not necessarily structurally primary keys on the tables, on the relations that we saw defined earlier. And that's how it's different, because it can be exposed. Primary key may or may not be exposed. A primary key can be a business key, or a business key can be a primary key, but there's some nuances there. In general, business keys ultimately are going to become hubs. And so a hub being a unique set of business key, link connects those, and then satellites describe them. Now, metadata, there are whole books written on collecting of metadata. But there's a few that are very important, and people could argue there's a lot more than this that are really important, or people could say there's a lot less. In my experience, these types of things are the ones that tend to come up quite frequently. descriptive metadata, structural, administrative, reference, statistical, and legal metadata. But metadata is how you describe the individual data or the data elements, the data structures, where the data is located, on and on. Again, these are all just definitions that we're going to throw together, and I'm going to use a lot in part two. Okay, so one of the things that we get when we're building a data vault is, of course, we've got to work with source tables. And we have to define the business key. We have to figure out what is a business key, where is it located, on and on. Now, in the perfect world, when an application team is putting together their application, they're going to create a data dictionary. They're going to create all of these definitions that are useful to use later when you do analytics and analysis. Yeah. One experience I had, I worked with building out a data vault. The number of definitions of the term product depended on who you were talking to. And there are a number of times, there's several times where I worked with an application architect where I said, hey, what are your business keys? And the usual response is, what is a business key? I don't even know what that is. And then we won't even talk about the number of times I've asked for a data dictionary and they don't even know what that is. So in the off chance that you have to go in and start working with a data model where it does not have a data dictionary, does not have good definitions, and does not have all of these other things, one of the things that you could do, and this is not the only way, but this is the way that I tend to approach it, is to take your data model from an application and convert it to that data structure graph that I defined earlier. So here is one that I put together, and you can see that this guy here, this little node here, this is the central node by graph definitions of the entire graph. So this vertex here is going to be one of the most important vertex in the entire graph. Okay, fine. Oops, sorry. I want to make sure I got the right thing there. Yeah. So one of the things, one of the advantages to creating a graph data structure over and above even just a standard ERD like what, for example, SQL DBM can create. Humans have evolved over millions of years to be very visual creatures, and we are able to notice things visually much quicker than you could through some kind of descriptive information. So here is an example. So I want to put this up here. Where is the frog? And I'll give everybody a couple seconds just to look at the image, because the advantage to this is a lot closer than it was in Vermont, right, Cindy? Let's see if this helps. We're going to put some grid lines around that. Is this easier to find the frog? Well, maybe not. But if you can find it, you can certainly tell others what cell to look at. You can communicate about the image itself, regardless of how the image is presented. And then finally, this is much more granular set of grids. So you don't have to say, hey, when you're describing this to someone, you don't have to say, hey, go to the shell. No, not that shell, the other shell. No, not that shell, the shell all the way there. And then go over to the right or what have you. You can actually say the frog is located in between cells T65 and U66 right here. So hopefully you can see my mouse so you can identify, you can see where the frog is.
Yeah.
So now coming back to this, when we talk about business keys, and you look at this from a perspective of a graph, where is a good chance that you're going to have business keys in this application data model? Well, my suggestion is uh, any table that is 1 sigma away from the mean degree distribution. So what that means in layman's term is anything connected to this central node here, that's where to look for your business keys. Oops, sorry. I clicked instead of just hovering. So if you have a large data model that you're beginning to look at from an implementation perspective, and you go talk to people about where are the business keys within the data model, if they don't know or they're not sure, by doing this analysis up front, you can, one of the things you can do is you can identify definitely where the business keys are not. And so anything that has a low degree, which a degree is the number of connections that a node is going to have, there's a good chance it's not going to have the business keys in it. The things that are in the middle of the graph that have a high degree, have a high number of connections to it, again, probabilities increase for this is where your business keys are. So this is a tool that I've used in trying to understand application data models that were undocumented, put together poorly, evolved over time, what have you. But by doing this, I've been able to remove the extraneous noise and get to these are the tables that are very important, and the attributes within these tables, chances are one of them is a business key. All right, so we've been going through a lot of definitions. Here's a nice little break. Hopefully the sound is coming out on this one. I don't know if it is or not, but this is I love this video, and for any of you that have seen me in person, I have a little snow owl that is sitting over my shoulder. She's called Marshmallow, and if you see me at a conference, chances are I will have Marshmallow with me. Maybe not at the right point in time, but at least one day out of the conference, I carry Marshmallow around and get pictures of people with Marshmallow. So that is the breaking point. I know we've got a few more minutes before the end of my time, but I'm going to stop sharing for now.
Yes. Hello. Thank you, everyone, for showing up today. Appreciate Doug, you sharing. What a great topic. I remember seeing it at the Data Vault conference back in the spring, so great to see it again. I am Mike Klusik. I'm the Chief Operating Officer for Infovia. And as the slide here shows, we are a holistic data strategy company. So we not only help organizations build their data strategy, soup to nuts, but we also then help them with execution on that. So a lot of times organizations will feel like, hey, I need a data warehouse, and then they don't think about all the other stuff that goes into that to get a good return on that investment. Things like data governance, data science, some AI, access control, a BI strategy, and so forth. So we help organizations develop all those capabilities, and then we will come alongside them and help them implement those capabilities as well. Big advocates of Data Vault, obviously, as a sponsor here of DVNAUG, and big champions of a lot of the automation tools that are out there, a lot of them that are sponsors here as well today. So a big part of what we're going to do with our clients is we'll come in, we'll coach them through not only how to build their strategy and present it to their leadership so they can get budget approvals and so forth. But then we'll also come alongside their IT staff and help coach them through that so that by the time we end our engagements, their IT staff is able to maintain and take care of the care and feeding of their data vault that we've assisted them in building. Or if they don't have an IT team, we can build it for them as well. And we provide some managed services that we put on the tail end of that so we can ensure that they can continue to rely on their data loading each night as they are sound asleep in their beds and they come in and all the data is fresh and loaded in the morning. We'll also come alongside them and help them with implementing more sophisticated strategies around data science and AI, as I mentioned. We also have an access control product that we have developed as a part of being in this community that is a policy-based solution that enables organizations to not only control who sees the data, but what portions of the data they see. So rather than having your typical report sprawl where you build half a dozen copies of each dashboard, depending on who's running it, you build it once for the broadest case, then you use policies. to control what shows up on that dashboard. So love to talk to you about it more. You can find us at infovia.com. And with that, I'll hand it back to you, Mary.
All right, thank you. That's Mike. Okay, and next up is Cindy Meyerson with Data Rebels.
Thanks, Mary. So thank you all for being here. We're always excited to get folks in here to see what we have to say. And so I appreciate being a sponsor here as well. Data Rebels is a authorized training partner of the Data Vault Alliance, and I am a certified instructor. Data Rebels also provides Kickstart and coaching consulting capabilities. Kickstarts are basically bringing you from start to finish, basically from source out to some outcome within a set 10 business day period of time. And it includes the CDVP2 training with it. So we basically take your team through training in a Kickstart, and then we immediately go into a build for a very well-scoped outcome. They've been highly successful if you're doing a proof of concept or something like that. They really work well to help the team not only get trained on Data Vault, but also to understand that you can deliver value in an extremely accelerated way when the team is working together using the disciplined agile approach for delivery. So that's what a Kickstart is. If you want to know more about it, you can go out to my website or give me a call. Happy to talk about it. And then consulting is really just a matter of coaching. I do not hold a bench of people in our consulting firm. I have some extremely senior level folks that I pull in when needed. And we genuinely, the desire of Data Rebels is to teach men to fish. We really believe in investing in your own people for training and also enabling them to deliver the type of analytics solution that will help your business not just answer questions, but also get into this mode of continuous improvement across the enterprise. So we take Data Vault at its core methodology and optimize not just the analytics solution, but also the way that the business is able to operate. So the whole goal there is to reduce re-engineering and therefore reduce cost while delivering a 100% auditable solution. So that is what we do, and I'm excited to be part of that. I'm also the COO of Data Vault Alliance, and so I'm in partnership with Dan and Sanjay Panda on a daily basis. We're working together. So I'll be excited to introduce Dan to you when he comes in for the Dan's words of wisdom. We've got a lot of really cool stuff coming up. So thank you, Mary, for handing it over, and I'm going to actually hand it back.
All right, thank you, Cindy. Okay, and next up we have Eon Collective, and we have Paul Kinnear. Are you here, Paul?
Hi, everybody. Yep, I'm here.
Great.
My name is Paul Kinnear. I'm the Director of Data Vault Solutions at Eon Collective. Happy to be here at another DVNAUG event again. We are the data modernization company. We are dedicated to excellence in the realm of data solutions, particularly in the fast evolving world of IT. We have a team of exceptional individuals who are passionate about transforming data challenges into opportunities. Our commitment to excellence is what sets us apart in the industry. We specialize in Data Vault 2.0 implementations, data governance strategies, automation, data cataloging, business intelligence, and so on. We'll guide you from your solution end to end. We've been working in the verticals of insurance, higher education a lot recently, medical and manufacturing. We have offices in the Northeast of the United States, as well as Kenya and India. And we have a large list of experts across multiple different Data Vault automation utilities, but as well as ETL tools and database tools. So that's Eon Collective, and I don't want to take up too much time. So thanks for having me, and reach out to Eon Collective if we can be of help to you. You can reach us at our website, eoncollective.com, on LinkedIn, or email. Thanks so much.
All right, thank you, Paul. And next up, we have Warescape, and we have Patrick O'Halloran.
Hey, Mary, thank you. Again, like Paul said, it's very nice to be able to sponsor DVNAUG and get a lot of knowledge out there. Doug, I appreciate your talk. As a math nerd, some of my favorite classes were on set theory, group theory, graph theory, and things like that. So what you're making is bringing back a lot of old memories. Warescape is a software vendor company. We have tools that help you design, develop, deploy data vault models, all the way from the raw vault to the business vault to a dimensional model on top of that if you need it for the semantic layer. We have about 1,200 customers around the world. We're not tied to any particular industry. We're pretty much in every industry you could imagine. I've been with Warescape about 4 years. I tried to find out when we started working with Data Vault, and I had to go to the Wayback Machine, if you're familiar with that, to look at our home page. And 7 years ago was the oldest reference I could find so far about when we started working with Data Vault. We've been working with Dan with Data Vault for that long. We've got great, wonderful tools. Everyone will tell you that whether it's Warescape or some of the other sponsors here, you got to go with automation. There's great pain associated with trying to implement a data vault by hand, and there's enough really good automation tools out there, including Warescape, that they're definitely well worth a look. I'll mention also that we are having a webinar with Dan tomorrow. You can register at warescape.com. We're going to be talking with a few of our current customers in EMEA and Europe and the United States about the success they've had, why they chose Data Vault, problems they've had, difficulties they've overcome, the great and wonderful things they've been building and how they're using it and getting great use out of it. And lastly, I'll just mention these numbers at the bottom. Data is just getting bigger and bigger and bigger. More sources, more types of technologies. I mentioned this to Doug yesterday, the zettabytes, the exabytes. There are massive things out there. You have to use automation to be able to create, design, create, and maintain any kind of large data structure, including Data Vault. Thank you, Mary.
All right. Thank you, Patrick. And now it's time for a 5-minute break. So I have it as 4:05 here in Texas Central Time. So let's just take 5 minutes and everybody take a bio break, get some water, and then we'll be right back with starting back up with the second part 2 from Doug, the data guy. Okay, you ready to get going again?
Yeah, I think Doug actually picked that up already. So, Doug, I think you're ready to go. We're going to actually get into the building and enrichment platforms section of your talk.
Yep, absolutely.
Fantastic.
All right, it says I'm screen sharing. So, just in general, one of the things about building an enrichment platform, data warehouse, what have you, why do we have to do this? Well, applications are designed with users, consumers in mind. What are the devices? What are they trying to accomplish? What are their individual needs? Optimizing a data repository for users or consumers requires an approach focused on performance and availability. So the data structures you may have, there may be a lot of redundancy. There may be some physical things that are done to the database. Anyone that has done database optimization and such, there's a lot of times where we have to do that for making application code work better or more performant. The individual applications that are built by application developers, their goals, their focus is performance, availability, answering questions by the consumers. Now, on the other hand, on the right-hand side here, we have our executives and business analysts. They're looking at the data from a very different perspective. They want to have a consolidated vision of the various things across the board. They want to look at total number of users and consumers, total number of products, etc. Do we have the right number of supplies for our supply chain? What have you? They're asking very different questions than the types of questions that are being supported and driven by the application. So this is the why we transform data. And for a lot of you guys, this is a lot of you folks, this is going to be obvious. It amazes me still to this day that when we do talk, when I get an opportunity to talk to someone, this is not as well known as it is within our echo chamber. So there are a lot of times where I have to explain this over and over again. That was where my first book came from. The Enrichment Game was explaining why you have to do these things. Um, Now, let's see here. Okay. So talking about, we mentioned the business keys earlier. So one of the, and I'm going to dovetail this with the earlier presentation where I talked about one of the first things that's important to building a data vault is the business keys. So this is one of the ways to help you find the business keys. So this little bit of math I'm going to explain here in just a minute, but I call it the entropy of a column. Um, Entropy is the entropy of any random variable is the average level of information or uncertainty that you're going to get from whatever it is that you're looking at. So this calculation, let me explain what it's doing. I'll read the definition so I don't go too far off the track. But for any column n with several rows r for a given period t, what is the unique rate of change of an individual? So the delta is a rate of change for an individual column, uh, the column you're looking at, and compared with the number of unique rows in this relation. So doing this calculation, and you can, I've got SQL queries that can put this together. I've got Python examples for how to do this. It's not that complicated, and the SQL is pretty standard, so it works on every database that I've used so far. But looking at the unique rows and the rates of change for those things across columns, when I first came up with this, when I first did this, it was very exciting to see the results because the columns that produced a number close to 1 were completely unique compared to the rows that were completely unique, which implies that there's some kind of identification in there. So if you think of, I'll try to put together just a very, a little high level example to explain in words that you can think about. Um, think about your address table. If you have an address table and you have some primary key because you have multiple people living at the same address, then you're going to have the address. But next to that, you're going to have something like a city, a state, and a zip code. Um, Cities are going to, so states are going to be the least unique of all of them because there's only a finite number of um, states. Cities, the cities, you can have the same city name in multiple states. So if you're just doing a comparison of the values compared to the values, the uniqueness of the rows, there could be some duplication. So that number could be a little bit higher, but that state value is going to be very low. It's going to be close to 0. Whereas the address, the 123 Main Street and on, that is going to have a high degree of, that is going to be very close to 1. And of course, the primary key should be 1 because it should be completely unique compared to all of the rows itself. So doing this calculation, and I'll relate this calculation to some of the other stuff we talked about earlier, you're taking a step in the right direction for finding those business keys. So at this point, if you do this kind of calculation on the columns in certain tables, and you have done the data structure graph approach where you're looking at the actual structure of the data and the degree centrality and such. So at this point, the only thing you've done that we've talked about is looked at the data model. You've spoken to a few application developers and you did some data profiling with this particular rate of change calculation to get the entropy of the columns. And what you end up identifying is out of 1,000 columns that you may have been looking at for the raw data model, you've got 15 candidate keys. So you come in, you do this, and you take this back to your business sponsor, which is always important to have for um, building a large data ecosystem. And say, we think these 15 columns are especially important in the application, and they may be something that are useful to you. Which of them are particularly important to you? That's going to be a very effective conversation. Instead of going, hey, we've got this list of 1,000. Can you go mark up the things that you know that you're going to need? They may or may not be able to do that, but structurally, you can identify these things. The irony of my claim here is that my claim is directly opposed to a few people. Dan, I don't think Dan has ever said this, but um, there's a few people in data warehousing space that say don't rely only on profiling data and don't rely only on, just looking at your source data models before you start producing things. Um, I'm saying you can get value out of looking at those if you take a particular approach. And then, of course, what's consistent with that statement is I'm not claiming you can just go build everything based off of the results of this math, but this will narrow down and fix the conversation that you do have with your business owners into a smaller and focused conversation. So you get more value out of the time that you spend. Now, one of the other folks that tends to present at the Data Vault conference is Bruce McCartney, and him and I have had a number of conversations. He does a lot of work with ontologies. So touching on these 15 candidate keys, if you plug those candidate key column definitions, trying to say that really fast, into an ontology, you're probably going to get some really interesting results as far as definitions goes, just in the overall space to be able to identify what this business key may be meaning to the business. And then again, you've got a high probability that you've really narrowed it down. This approach may miss some. I'm not claiming it's 100% accurate, but there's a good chance you take this approach, you're going to be very close to finding business keys. Um, Finding links, that is the next part of that. If you do the same thing, you use the same bit of math, um, then you identify a table that has at least two of those business keys in the same row. So if there, that should be in an application table. That should be something we used to call a junction table. That should be relating those two things together, because not all applications that are built on relational databases properly enforce foreign keys and things of that nature. But chances are that's going to be a link, and it has to be. It's going to have at least two, because links, of course, can be more than two. Okay, so um, I talked about this a little bit. I mentioned the why earlier. Why are we transforming data from an application into an enrichment platform? Once you've identified structurally the hubs, links, and satellites, the data's got to be transformed into these structures. And one of the things that I found I've talked about the foundational literature, some of the books some of the books that Date wrote, and some of the papers that Cod wrote. If you look at some of their research, not a lot is mentioned about transforming data from one data structure to another. It's not that it wasn't important, it's just that was not the focus, because as I learned from Chris Date in Vermont at the beginning of the year, some of the arguments that they had were just getting people to implement the relational data structures over some of the other database models that were out there. So they had different challenges to deal with than some of the things that we have to deal with today. But as part of that, one of the things that we recognize now is you can have multiple databases within an enterprise. Chances are, if you have an enterprise and it's only running one database, it's a very small enterprise. So pulling data from a source system, adapting it for a target system, making it more useful, enriching that data structure to do stuff with it. That is a data transformation. Um, in a lot of the research that I had done as I was working on improving myself to become a data scientist, I happened to stumble on a branch of mathematics called category theory. And the category theory, in broad terms, and I am not an expert, I don't pretend to be, I just know enough to be dangerous with category theory. Category theory allows you to change one mathematical object to another. In our examples, it is transforming, for example, a set to what is called a group, or a graph to a topology, or something of that nature. So mathematically, when you're building an ETL platform where you're reading from these source tables, and I have these mentioned as a subgroup because, and I think I might have jumped ahead with the terminology, but there's reason to believe, and I'm still doing some research on this when I when I have time. There's reason to believe that a relation as defined by COD is actually mathematically called a non-abelian subgroup. You don't need to know what that means, but it's an interesting thing that I'm researching that one of these days I'll have more to say about. So mathematically, what you're doing is you're using category theory to transform data in a subgroup into a set, which is going to be your hub, or another relation, which is going to be your satellite. For links, these are going to be your tuples. So you're doing, you're transforming this data from these various subgroups into others, which are creating sets, tuples, and or other relations. And yes, okay, here we go. This is where the definition is. So the tool that does that is what's called a functor. This is if you're taking from a subgroup into a set, you're actually using what's called a forgetful functor. And then all of the above. The forgetful part of the functor means that the structure that the source is has provided is different than the target. And this is exactly what we do with source to target mappings. So in our world, this is an ELT process or an ETL process. I was very excited to learn this because one of the things that, as I've learned and done ETL, I've been doing this for years. As you saw from my first slide where I talked about working Desert Storm, um, I, I really struggled to that there was not really a mathematical. I could not find a mathematical definition for how you would transform one thing to another. And so when I started learning about category theory, I got really excited, and I have a number of books, and eventually I'll understand them. Uh, but I do know enough to know that this is exactly what it is. And I've talked to other mathematicians about this and explained my thinking on the relationship of uh, one thing to another. And everyone that I've talked to that has some familiarity with category theory tends to agree with me. Now, this is where I make a mention of the non-abelian subgroup. Um, as I mentioned, more to come on that, and it has to do with the reason it's non-abelian. It has to do with the sequencing. So, as I mentioned, the table earlier for address, city, state. Uh, if you do a query and you change the sequencing from city, address, state, you're going to get slightly different results. That's what makes it non-abelian in a nutshell. Okay, so what have we defined up to this point? We have a process now. And yes, I've been doing a lot of hand wavy things, and I've been talking about a lot of mathematical terms. But how do we apply this to the business? How do we get value out of this? So the value comes from the process that we're creating. So you can analyze an application data model with graph theory, identify the tables that have a certain level of degree, profile the data that you've identified from step 2. So in other words, you're not profiling every table in the database. You don't necessarily have to. You might want to, but you don't necessarily have to. But you get the column entropy for those tables that you've identified being close to the central table. And then you have a conversation with the business. Um, that's not to say you can't talk to the business ahead of time, of course, but um, bringing this information from doing research as you start putting together a project, this is going to be very useful. And then from here, once you have these business keys confirmed, you use those business keys to identify the important relationships. Those are going to be your primary links. And then you gather the contextual information about all of those things and put them in satellites. This metadata now, you put that into an automation tool. And now you've taken and done some really interesting analysis, and you put this in your automation tool of choice to get it implemented. And my claim is you can turn this around very quickly to be able to produce um, at least a prototype very quickly using this approach to get to where you're showing value to either your customer, well, however you define your customer, whether you're a consultant or whether you're working for a company and you need to build this thing out. You can do this. And the other comment I'm going to make about taking this approach is you're looking at data. You're focused on data. You're not going into dealing with all of the infrastructure stuff and all these other things. And the hope is, of course, you're relying on automation tools for doing that part, but then generating some of this other stuff, some of the data structures, use other automation tools for that. Focus on the things that a human can provide additional value for. Humans should think, machines should work. Now, when we talk about the satellites related to a hub, I have a very small example here. And I've heard repeatedly, storage is cheap. Well, sort of. Um, Specifically with certain other databases, certain cloud databases, they actually uh, charge customers based off of storage needs. So depending on how you store your data can affect your bottom line. Um, so let's go look at how many satellites do we need to connect to a hub? Okay, so one of the mechanisms that I came up with for uh, playing with this at first is this little calculation. How many select queries, no group by, no where condition, you're not casting one column as two or more, any of those other things can be formed just from the definition of a table. So for a table with a number of columns C, the number of select queries that can be formed from the table definition with no aggregation or conditions or anything like that is 2 to the C minus 1. The reason it is 2 to the C minus 1 is, and this has to do with things like the fundamentals of the binomial theorem, uh, you cannot run a select with no queries against the table. Otherwise, it would be 2 to the C. So the 2 to the C minus 1, and we're going to get to where we use that here in a second to do some, I think, cool stuff. All right, so if you have a single satellite with 40 columns, including all the metadata columns, etc., and you do the calculation of 2 to the C minus 1, you have 1.099 times 10 to the 12 possible queries. It's a lot of queries. This is, you're never going to use this many queries. It'll never happen. But if you take that and you combine it with the volumetric data, all right, so think about the volumetric data associated with a 40-column table. That table is going to be huge. And so when it comes to space requirements, regardless of the database, you have things 40 columns wide, and a billion rows deep. That is using a lot of data. Now, does this one satellite need to have 40 columns? Well, maybe not. let's use our column entropy calculation against a satellite and see what we can find. So using that, let's say we identify 3 different clusters uh, of of data that has, and where these clusters come into play. This is data that's not necessarily, you're not looking for primary keys here, but you're looking for column entropy similarity in this case. So you have 3 clusters of 20 columns, 15 and 5 columns that have a very similar rate of change, using something like k-means clustering, for example. So if you break that one satellite down into 3, you've cut the number of queries that are, even if you were to join all 3 of them, down against all 3 of them versus the one by an order of magnitude. Combining that again with the volumetrics, you're going to have 5 columns with a billion rows. Well, chances are that that may be very sparse data. Again, you're going to change the sparsity of how things are looking. Or those 5 columns, if you break them down into something unique, it may not be a billion rows. It may be that this may be city state, zip code type things. So those 5 columns will go down to, um, 100,000, for example, instead of a billion. There's some, depending on how you do this and depending on what the data is actually saying to you based off of the column entropy analysis, uh, you can organize your data much better. All right. So I think Dan's listening. This is one of the first things that I ever sent to him, and he was like, "This is cool. I'm not sure how we can use it." Well, I don't know how we can use it either, but I'm going to talk about it. I mentioned that tuples before, and tuples are basically just combinations of sets of numbers. So let's say we talked about the satellites associated with a hub. Let's say we've got a link tying together 2 hubs, hub X and hub Y. We're just going to go with some very simple terms. Um, the link L is here. We got a nice little triangle here representing it. Um, so before you do anything useful, you got to do the transformations and create a dimensional model, add some things to a fact table, and do visualizations on it, right? You have to take the data out of the link table before you can do any analysis on it. That's what I'm trying to say here. Not necessarily. So if we look at the rates of change of the data within the link and we profile it correctly, we can represent this as a mathematical expression. The rate of change of each hub would be delta X and delta Y. That looks very similar. You've now got dx dy. This is standard calculus. So you've translated data structures and how they're holding the data into something that you can apply uh, normal calculus measures. So what is the relationship between X and Y? As always, you could say it depends, but there's also a good chance that you could run this math on it and say, here's um, this is the acceleration, this is the velocity of how things are changing. Um, when this goes up, that goes up. There's a correlation here. There could be some interesting things here. Now, if you have a link with more than 2, uh, representing more than 2 hubs, you could end up having some very sophisticated partial differential equations like these. In the case of things like fluid dynamics and aerodynamics, generally this delta x, delta y, delta z over, or partial x, partial y, partial z over partial t, this is always equal to 0. Well, that's because physics has certain rules associated with it. The way applications are built and the way people use data is a little different. I'm not gonna claim the equal 0 needs to be here because these are not always going to be equal to 0. In fluid dynamics, if you push something up, things have to go to the side. In retail and other relationships, they may or may not, but you can start with this type of thing as your analysis, just looking at the link. Before you do anything, before you create a dimensional model, before you do any kind of visualization, you can get some really interesting numbers and run it through some R packages to get some interesting results here. Another another way to look at a link is a graph interpretation. So if you just take the results of the link, or take the data from the link, dump it out to an analysis tool like Gephi, for example, which is what I use to produce this, then you can see a graph relationship, and this is called a an n-part-type graph. So the n is going to be the number of columns, the number of hubs that are represented by the link. So this is going to be a bipartite graph. If you have three hubs that are represented, it'll be a tripartite, on and on, on and on. So what you can do with this kind of analysis, if any of you, I believe they're called Sankey diagrams, you can create things like Sankey diagrams with this. You can do just regular graph analysis, look at from layer 1 to layer 2. These are the things that are most important. These are the ones that have the high degree connections. So there's some very interesting analysis that can be done and can be provided to as part of an overall analytics approach, just by looking at the structural data of the data vault and how data is put in there, how it's represented, how it's stored. And you don't have to move the data. You don't have to then take it out. You might want to, of course, but you can do other things within the data vault itself before you move it. Okay, so now I'm going to touch on hubs again. So I covered some interesting properties of satellites and links. Let's return to hub. Just having a hub with a satellite, you can do some very interesting data science work just with that. Assuming the business key is a customer and the various attributes that you have in the satellite are all demographic, you can apply clustering to that and that alone. This is data science on Data Vault with any additional structures or any movement of data without doing anything else. A really cool implementation of something that there was in the chat earlier, somebody mentioned probability. Let's take a little bit of a diversion here. What are the odds of number 1 coming up in the roll of a fair die? Hopefully this will be pretty easy for those of you that have some basic probability theory, 1 out of 6. Well, where that number comes from is there's a total of 6 expected values, and whenever you do a roll, one of them is going to come up. Assuming you have a product hub, the odds of any given product being chosen at any given time is 1 over the number of rows. Period. That's by definition. This is the definition of what a probability is. And because a hub is a set, which is unique, you can do all kinds of filtering on that with the satellites or the anything associated with a date for a particular range. And you could say, okay, for this product was chosen a lot, this product was chosen a little. The expected outcome is this is what it should be chosen. You can work with probability again within the data vault structures without moving the data. So one of the reasons why I really want to call this out is there are lots of claims out there, and I consider them to be valid claims, that the majority of your data scientists are going to spend the majority of their time pulling data from wherever and munging it to make it useful for their statistical packages or what have you. Well, with a little bit of education and explaining to some of your data scientists what the data vault structures are in mathematical terms, which is what a lot of that's the terminology that many of them speak. And I'm including myself in the them there. There's nothing bad about that. I'm just data scientists have spent a lot of time understanding different things rather than data modeling. So if you explain the data structures and how they work and how they apply to various different types of analysis, they can use these structures without doing any data munging, and you're helping them provide value. which by doing that, you're providing value to them. So they're going to come back to you, to the data architects of the world. All right. So just one of my favorite quotes here: the laws of nature are written in the language of mathematics. The symbols are triangles, circles, and other geometrical figures, without whose help it is impossible to comprehend a single word. So it's my presentation. I get to put in my favorite quotes. Now, this is something that I brushed on this, but I didn't call it out specifically on an earlier presentation. Doug's performance law. What does not get organized with a data structure must get organized with application code. I wrote a blog about this some time ago, and it's still out there, so you might find it on my blog, thedataguy.blogspot.com. Occasionally, I'll update it. What this all means is, depending on, there's so many dependencies here. So this is disk IO. If you have a very granular query, which is very detailed, and as it goes up, the database, the work necessary on the database will change. The front end volume of data that it has to work with changes. So depending on how you do your query, there's a relationship between the granularity of the query and the data that has to be processed by the front end. The more you can improve the data structures associated with queries to make the application work better, again, the better you're going to be. And there is an inverse relationship. This is originally, I was dealing with this from a business intelligence perspective, because I was working at explaining that if we were to take if we were actually to do some good design work, we could design a database, design some data structures that would make performance of the front end much better. So as the performance requirement of the database goes down, or if you're doing select star from table X, just give me everything. Well, if you do that, the disk IO and the CPU memory utilization of the database is going to go down. Okay, so you've improved performance there, but you're taking that volume of data and you're going to shift it. So here's bandwidth. So it's going to be huge, and it's going to go to the front end, and now the front end is going to be dealing with performance issues. So on the left here is disk IO, on the right is bandwidth. Here we have data size. And so you can see if you increase the utilization on the database and create a very sophisticated query that spits out a couple of results, the data transferred on the network, from the server network back to the user network, and then ultimately the memory necessary and disk IO of the front end is going to be smaller. This is how the relationship works, depending on how you do this. So if you have that select star from table whatever, the database, it's not gonna be a big deal. It's just going to dump the data back out, but then you have to transfer this data and then transfer that from the database to whatever the application server is, in this case, a business intelligence server. And then depending on the work necessary on the front end, all of that data could potentially ultimately go out across the network, the user network, and then that'll take a while. And then it'll also use up a lot of resources on the front end. So there is there is a fixed relationship between performance of a database and performance of the front end, whatever the front end is, whether that be an application, whether that be a business intelligence server, any of those kinds of things. And for those of you that are familiar with this diagram, this is the same kind of math that you do in economics, which is supply and demand relationship, only it's data. Now for the presentation layer, and here I'm going to mention my performance law again. We generally will put things into a dimensional model. There's a lot of tools out there that make dimensional models less and less important, but for the longest time they were. And I still think that a dimensional model is reasonably important for getting out to your presentation layer, but that's my opinion. So remember that expression we were talking about? That's the upper bound. So If you have a fact table with just one measure, the total number of queries that can be run against a dimensional model now is pi I to the n 2ci minus 1. But you only count the things that are connected. So this actually becomes a little bit more complicated, a bit of math. And that is one way of measuring how how useful your dimensional model is. One of the other things that I realized about a dimensional model is a dimensional model is really a physical structure that implements combinatorics. And combinatorics is a very fascinating mathematical subject, which is all about different ways of counting things. A dimensional model, all it should be doing is allowing people to count things based off of different dimensions. That's it. When you get to where you're using a dimensional model for other things, you're probably using it the wrong way, and you really need to review data vault techniques. Maybe have a conversation with Dan, and he'll educate you on the difference. But counting measures, this is that's combinatorics. That's just the way. That's the mathematical subject that is being done there. Okay, so now we're going to expand the process. I think we got up to step 7 before, but now we're going to add a few more steps here. We're going to deploy things to the database with an automation tool. We're going to expose these data structures, how they're used in Data Vault to your data scientists, and allow them to use things there. And then iterate and focus on business value rather than all the low-level infrastructure details, because focusing on business value, that is going to be the thing that we need to do. Now, I want to mention this. It might be in a later slide, but I just want to make sure I don't forget it. In the Warescape slide that we covered before we jumped into part 2 of this presentation, they had some really interesting numbers. And in Vermont, Dan made some mention about volumes of data and things of that nature. And I'm not going to try to quote him because I forget the exact quote he said. But the volume of data is increasing, period. We know this. This is a reality. We all have devices in our pockets. Some of us have more than one device in our pocket. And you know that data is increasing, and you know analytics is going to need to be done on it. If you are able to do, the more capable you are of doing analytics in an integrated repository, such as the Data Vault, the less you have to move the data. When you're talking about petabytes, exabytes, and on, all these other prefixes that we're just starting to get familiar with, the higher the volume of the data, the better you're able to continue to provide value by looking at how the structures are helping you in doing your analytics. Now, so this is something that I'm hoping every one of you takes away from this. What math do you work with every day? So whether you realize this or not, as data architects, as data engineers, certainly as data scientists, you absolutely will. You're working with calculus, combinatorics, category theory, economics, graph theory, group theory, information theory, ontologies, probability, relational theory, set theory, and topology. People have asked me in the past, why is this stuff so complicated? And so when I created the slide, I want to keep it in my back pocket and just say, this is everything that we really are doing under the covers. So a couple of quotes that I like here. The definition of genius is taking the complex and making it simple. I think Einstein said that. And a problem well defined is half solved. So just a call out to the team, Dan, Cindy, Kent, and others have been teaching these principles for years. They are the true geniuses. This stuff is complex. The only thing that I've done is given a vocabulary to what you're already doing. With Data Vault, the mystery becomes a puzzle. These principles can be a guide for you to translate poorly done application data models into an enriched data model that opens the door for analytics and insights within your organization. This is going to increase your value as an individual. If you stay out of the weeds and you're focused on the business value, that's going to demonstrate your value to the organization. The only thing I've done with this presentation is just name the parts. These are the parts that you already use. Uh, I haven't really done anything special other than categorize this stuff. Now, translating, this is something that I've had a couple people ask for, translating data architecture into data science. Um, we know we have a different language than application developers, and data scientists use different terms for what we work with. The big thing to remember when working with data scientists is they're really looking for three things. That's it. All of data science can be boiled down to these three things: similarity, context, and relationships, period. Um, both data architects and data scientists do talk about the same things, but they tend to both talk about chairs. A feature set, this is a table. It's just a table that can have many columns. A model, this is a machine learning model. It's an object along with a code associated with it. So it's data and application code bundled together. That's going to be your data science model. And so using the example I talked about before, everybody's talking about chairs. This is what a data scientist thinks of when they say a chair. Um, from the data science perspective, this is what a data architect chair is. This is your application developers, and then here are your users. Um, and okay, so this is something I'm going to read, and I think we're going to distribute these slides, Cindy. I hope so, but if not, I'll read this for the recording. So if leadership says we don't have time for a data warehouse build, ask them this. Okay, can we build an enrichment platform to support data science efforts that transforms data using functors, supports probability analysis, set theory clustering, graph analysis, topological analysis, n-dimensional dynamic data representation, produces data products that can support combinatorial reporting by connecting to an ontological knowledge graph where we can reduce the load of any front-end data analysis by applying economic supply and demand theory?
Can we get that on a flashcard, Doug?
Yeah, I know. So whenever, save this, keep this in your back pocket, because whenever somebody says, we don't have time to build a data warehouse. Oh, okay, can I do this? Oh yeah, that sounds really cool. And I should probably put something about Chat GPT in there too now. All right, last slide for me, and we got about 5 minutes left, is um, uh, regardless of all the other stuff that we talked about, one of the principles that you should keep first in your mind is be greater than average. Don't be intimidated by credentials, because really we're all mathematicians. Everybody working in any kind of data architecture role, data engineering role, you're applying. You may not be thinking about the math that you're actually applying, but you're implementing a lot of mathematics under the covers for your daily work. And that's it. Thank you,
Doug,
everyone, for joining us. So I think we've got some time for Q&A now, right, Cindy?
Yeah, I think so, Mary. Thank you so much, Doug. This is one of the reasons why we love having you at the conference. So I hope you're coming back in the spring. So be thinking about that. This was fantastic.
Yeah, I don't see any questions on the chat. So if anybody has any questions, just
Well, I saw a hand
please.
raised. So the only hand I see up now is Brian. But I thought I saw another one. Okay, go ahead, Brian.
You're getting some rave reviews.
Yeah, great to see this again. Thanks, Doug. I'm interested to see how you see this being incorporated in the automation space and tooling around building these data products.
I'd be interested in seeing that too.
Okay.
Einstein didn't build the atomic bomb. Oppenheimer did. And so the only way that I'm comparing myself to Einstein in that regard is this is a lot of theoretical work. It's not how something is implemented. I mean, yeah, the process is there for applying some of this analysis, but it is other people are going to have to dig into this to see how this would be applicable in automation tools or in their regular processes of working with customers. I've used bits and pieces of it off and on now for a long time, uh, but it's just a matter of getting more people familiar with these mathematical tools and then having other people use it in the real world. Because yeah, it worked when I did it, but I'm only one person, so I need kind of need more data, and I'd love to see more people try this stuff or experiment with it and figure out how to apply it, and then maybe reach out and tell me, hey, I tried what you said and it didn't work. Okay, cool. Let's see if we can figure out why. How do we change it? How do we make it better? That kind of thing.
I can't wait to see the Oppenheimer who comes out with it. This is a great talk. Thanks.
Mm-hmm.
All right, if we don't have any more questions, thank you so much, Doug. We all loved it, and the comments that were going back and forth in the chat were awesome. You should check them out if you get a chance. So I guess we'll go ahead and move on. Thanks again. So I know Dan was on most of the presentation, but he had to step away. So Cindy, did you want to give us Dan's words of wisdom?
Sure. And before I do that, hey, Doug, if you can get us your presentation, we'll put it in PDF and get it, make it available for everyone.
Okay, thank you. I'm glad you answered that. So I'll
get I think that would be great to be able to get that out to folks. So yeah, thank you for offering to do that.
Problem.
Okay, so Dan unfortunately is recovering from COVID, and he hung until as long as he could, and his head is pounding. So he did have to drop off, unfortunately. So you're stuck with me. I apologize. So Dan's words of wisdom. A couple of things that we wanted to say. We love to be, like lifetime learners. That's one of the things that I think a lot of our community actually enjoys along with us. Dan is a lifetime learner. He's always researching and studying and reading up on things and looking for innovation and things like this. So along those lines, one of the things that he's doing right now, we're about to release the CDVP 2.1 class. And we're offering a preview. One of the things he's looking for is we've made some serious modifications to our learning platform, basically taking feedback from folks that have been in the 2.0 class and adding in a number of sort of interactive features into the CDVP 2.1 class, along with an extension on the materials. The day one, if you guys have gone through the training, the day one materials generally are about 100 slides. Day one materials right now with 2.1 are over 500 slides. So we are going into a tremendous amount of depth in a number of areas that are new for us as far as having that content in the class. We will be looking at data lakes, data lake houses, data mesh, data fabric, data hub, etc. We're going to be looking at various architectures, along with deeper dives into things like data mesh, late arriving data, temporality, some things that we touch on in class, but we don't have time to actually go into in depth. So we're expanding it. We're going to include things like dealing with JSON and things like that. So we are doing a preview class starting December 11th. That's Monday, that we're offering to everyone, just to let you know. If you've had CDVP2 training and you've been certified, you can attend this class, enroll in this class. And then what we're looking for is feedback from everyone. So as Dan is teaching this class, he's going to be teaching this class. It is an 8-day class right now, so it's a big commitment for folks. However, you don't have to attend the whole thing. If you can pop in for a couple of hours, provide feedback on what you're hearing. He's going to be asking questions and things like that about the format of the class, what you might want to get more out of in certain areas. That's what we're looking for. And the class is being offered for, I think it's under $1,500. when the class is released in its entirety, if you've been in the preview class, you get to attend the 2.1 class, the full class, at no cost, no additional charge. So you're basically getting a 50% discount to enable us to get feedback from you. So it's going to be a great deal for folks. The other thing you'll have access to clearly is the certification. So the 2.1 certification test. There's only like 1 day left to enroll if you're interested in this, but this is what we're offering. We'll also be offering this class in January, but it'll be on a 5-day schedule. And so anyway, we're going to take the feedback that everyone gives us, and we'll continue to enrich this class. So that's what this slide is about. This link that you see at the bottom, if you're interested, will certainly let us know, and I'll try to get that to you. If you pop it in the chat, I'll try to send you an email or something tonight, so you can enroll if you're interested. So next slide, please, Mary. Thank you. Or Janet, I don't know who's driving, sorry. The other thing I want to let folks know again is, if you enjoyed Doug's talk, this is the quality and the caliber of the presentations that you'll get at the Worldwide Data Vault Consortium. And so this year, CJ Date is coming back this year. He is going to be presenting on temporality. His temporality presentation is generally about a day and a half seminar. So he's going to take 2 hours and do the first part of temporality. He's broken it into 3, sections. He is offering to do a 1-day seminar after the conference on Saturday to actually do the full lecture he has on temporality. So we're going to be sending a survey out to folks to see if you're interested in going to Worldwide Data Vault Consortium. Would you be interested in staying, 1 extra day? We end on Friday. Saturday, CJ would complete his seminar, his lecture for a group of folks. And the other thing we're looking at doing this year too is doing a 2-day workshop before the conference starts. Scott Ambler is looking at doing his Agile Leadership and Agile Teaming workshop on Saturday and Sunday before the conference starts. So you're going to be getting probably some of you may be getting a survey from us asking, if you'd be interested in either one of those. We're not committed to delivering those yet with the conference, but that's what we're thinking about doing. So our conference, if you want to go out to our www.dvc.com, you can look at the themes that are being offered this year. We have some great speakers coming back, and one of those will be CJ Date. So we're excited about that. The other thing we'll say right now is we're also offering a membership. You can actually join Data Vault Alliance. There's some great materials out on the website that are free. There's a starter membership that you can join. You can look at past conference materials. We also offer a professional membership for folks. If you really want to learn more and get deeper into Data Vault and ask Dan questions directly, the professional membership, we offer once a month, we do a webinar, and it's a Q&A session with Dan and Sanjay and I. And so you can ask Dan directly any question you want to ask him. And so in addition to that, we do once a quarter, we do a concept teaching webinar for pro members. Today, we actually did a sort of a sub mini course, if you will, on data contracts with regard to data mesh and how Data Vault supports that concept of a data contract. And so that is not any material we've delivered anywhere else before with regard to data mesh and data contracts. And so we're starting to do some things like that. If you're interested, just check out the website as well. I don't know what else Dan had on his words of wisdom, unfortunately, so I can only deliver what I see on the slides here and let you know. But if you're interested in any of these things, please just, let us know. You can always get us at contact@datavaultalliance.com, ask questions or whatever. So thank you for your time.
All right. Thank you, Cindy. And now for our giveaways, Janet, take it away.
Okay, thanks, Mary. You can keep sharing the slides though, please. My computer's acting up, so I can't do that. So all of our sponsors are very generous, and they give us gift certificates or books or other things to give away as part of our events. Now, we do draw names ahead of time based on the people who opted in for the meetup. So you don't necessarily need to be here to win, but it's always fun when we have people here when we do the draws. And we do get in touch with all the winners via their email addresses that they provide for us, and we put them in touch with the various sponsors, and the sponsors then provide the gift cards. So Mary, do you mind switching slides for me, please? All right, so first off, we have from Resultant, we have a $50 gift card, and the winner is Kathy Wang. Congratulations, Kathy. Data Rebels, they're giving away Choose Your Wow, and the winner is Dustin. I am sorry, I'm bad at names, so I'm just going to leave it at that. Congratulations. Eon Collective, a $50 Audible gift card goes to Sadir Kumar, who's a first-time DVNAUGer, so that's kind of cool. Wearscape, a $50 Amazon gift card goes to Dave Mortensen, and Vault Speed is giving away an assortment of Belgian beers, and that goes to Babik. Yes, I'm just going to leave that. Sorry. Who is also another first-time DVNAUGer. The Seven Rivers is giving away an Amazon gift card, a $50 Amazon gift card, and that's to Shakanya Kaspa. And then SQL DBM, a $50 Amazon gift card for Emily Stanborn, who's a first-time DVNAUGer. And Data Vault Builder, it goes to Simon. And for Infovia, the $50 gift card goes to, this is the last one, Sebastian Puig. Congratulations, everyone. And we'll be in touch for how you can get your gift cards. All right, thank you very much.
Chat us. It's really exciting when people are here that win. All right. All righty. So we really appreciate everybody that stayed on the whole time and that attended, and hopefully you enjoyed this session of DVNAUG, our quarterly event. And we just want you to mark your calendars for the next event, which will be on March 20th and at 3 p.m. Central. And it's going to be featuring Kent Graziano. And he is going to be introducing a new Data Vault acceleration tool, which is called Fluid Data Vault, and it's by a company called Zetaris. So we're really excited to see all the new tools that are coming out here. Anyway, that is it for our event. We hope you enjoyed it, and we hope to see you at the next one. Thank you so much.